Okay, so we go ahead on the three-phase rectifiers. It's a rectifier, AC to DC conversions, that is called rectifiers. It's a three-phase rectifier. What is a three-phase? It's a input is a consist of three phase, R phase, Y phase, and a B phase. Or you may be right about A, B, C. What about that? These three phases? Okay, this is a input sine waveform. So what is the angle between one phase to another phase? So A phase to B phase is a angle is a 120 degree. B phase to C phase is angle is a 120 degree. So see the waveform. So A phase is conducted after 120 degree. B phase is conducted after 120 degree. C phase is conducted after 120 degree. Again A phase is conducted. So this is a phase sequence. This is a phase sequence of that ones. Okay, so what about the output waveform? Output waveform of the output form of the low voltage as well as output voltage of the current, both also same. What is here? So here, like, this is a type of the thing. So you can draw here. So you will going to join here. So like easily we will going to draw the waveform. So one more time you will going to draw the input waveform, and then you will going to draw. Okay, this is a method you will going to draw for the output waveform. See the here it's output waveform. Okay, coming to the points. Okay, about the operation of this three-phase rectifier. So how it will going to operate it? You have see the tabulations. There are 6 steps. So 6 steps. The concentric steps. The each step two diode is operated. What is angle of the conductions? This is the angle of the conduction starting, ending. First mode, it is a conduction period. Okay, what is the duration? It is a 60 degree duration. Each mode is a duration is a 60 degree. So this is about that operation. Okay, how it will going to operate it? RY. So phase number RY, or you can say about that AB. So AB. So next one is a AC. Next B phase BC. Another one is a BA. Next one is a CA. CB. Suppose you are giving the name as an ABC, that's why. So like it is a phase is a, or it will going to operate it. If this phase is operated means, so these two switches are closed. One switch is from the top, one switch is from the bottoms. How about the switches given the name? It's a given the top is the odd number, bottom is given as an even number. So what is the top odd number? 1, 3, 5. Bottom is starting from the 4, 6, after that 2. Why do they given the numbers exactly here? Why do they given? Why they don't give for 1, 2, 3, 4, 5, 6? Because this is a point of the diode is operated after 60 degree. This point of the diode is operated. After that, this point of the diode is operated. After the 60 degree, this point of the diode is operated. After 60 degree, this point of the diode is operated. After 60 degree, this point of the diode is operated. That's why they are given the sequence like that one. Okay, what are the 6 steps? Okay, conduction of the diode: 6, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. This is the diode of the conduction of the sequence. Okay, what is the angle? First diode is first step is conducted. So 6 and 1 of the diode is conducted in the angle starting from the 30 to 90 degree. 30 to 90 degree. Then after that 90 to 150 degree. 150 to 210 degree. 210 plus 60 270. 270 plus 60 330. 330 plus 60 390. So 390 means it is a more than one cycle. So 30 degree. So that's why the first mode is not start with the 0. Why the mode 1 is not start with the 0? Because previously conducted diode, due to the previously conduction diode up to the 30 degree. So mode 1 is start from the 30 degree only. The mode 1 is start from the 30 degree only. That's all. And what are the other points you can say? So each leg there are 2 diodes connected, D1, D4. When okay, at a time D1 and D4 is not closed. Why not closed both diode at a time? If it is closed means it is a make it as a short circuited. It is make it as a short circuit across the load and the source. So that's why. So at a time either D1 is conducted or D4 is conducted. How about the angle differentiation? So 180 degree angle differentiation. D1 conducted. After 180 degree, D4 is conducted. So you can look the diagrams here. So where is the D1? So D1 is conducted. So here, okay, it is conducted. After that one is here is there. After 180 degree, D4 is conducted. See there. So like about that one. so the angle it will going to difference between the D1 and D4. Similarly, so D3 after 180 degree D6, D5 after 180 degree D2 for avoiding the short circuited. So each diode how many angle is conducted? 60 plus 60, 120 degree angle is conducted. Each diode 120 degree angle is conducted. So this is a one slide is I gave for that all the information I gave you for that entire 3-phase rectifiers. Okay, so equation wise, so when you have see that one VAN, VBN, VCN, I have written similar to the single phase. Single phase A to N means N for neutral. Okay, phase second phase to neutral, third phase to neutral. What you were written? Vm sin omega t. Next one 120 degree angle differentiation. Next one is a 240 degree angle differentiations. I have written single phase. Each phase wise I have written. I need the VAB. VAB means VAN minus VBN. So I will go to subtract it. I will go to get the equation. Similarly VBN, VCN, VCN minus VAN. So VCA I will go to get it on that once. So next one I will going to substitute the first step. Step number 1. What is step number 1? Conduct from 30 degree to plus 30 plus 60, 90. So pi by 2. So I will going to substitute it and then take the integrations, and then I will going to substitute the formula A sin A plus B, and then I will going to substitute the values, and my answer is this answers and IDC. Like you will going to go ahead on that ones. So VRMS means square root of the V average, and here is also 1 square. So you can look it and then see it. Okay. So what about the mode 1 diagram? I explained in that during the regular class times. Mode 1 diagrams. For example, mode 1 is a 6 and 1 is operated. Where is a 6? Here is a 6. 1 is here. Okay. 1 from the upper, 1 from the lower. What about the mode 1 of the phase sequence? So you can see that one phase sequence is a AB. Or RY. AB is conducted. Where is the AB? First one. So here A to the D1, D1 to the load to the D6, D6 to the B phase. So like about the you will going to draw the mode diagram. Okay, the next one precision rectifiers. So why do you go for the precision rectifier? Off-wave rectifier it has the drawback. Off-wave diode rectifier it has the drawback. What is the drawback? Okay, it will go into threshold voltage is taking. What is the threshold value? 0.7 voltage. Very smallest 0.7 voltage. It's a problem. Yes, it is a problem for that is small. Okay, signal conditioning type of application as well as demodulation type of the signal, demodulation type of the circuit. Even that 0.7 also important. Okay, so that is a threshold. How to avoid it that the threshold? That's why you can go for the precision. What is the precision? So here between you will going to connect one operation amplifier. If you will going to connect an operation amplifier, what you will going to get the transfer characteristics? Your waveform is start from the 0. Your waveform is start from the 0. Where is the waveform? Yes, it is start from the 0. See here I have connected one operational amplifier. What is that one? There are two input operational amplifier. So like I will going to connect it on that one operation amplifier. Okay. So here is what is the mode of operation? There are two mode. Mode 1 is that here diode is forward bias. Mode 2 is a diode is a reverse bias. Okay. Mode 1 it's a close. Mode 2 is a open. So mode 1 is what about that one? Input voltage is greater than 0. Mode 2 is the input voltage is less than 0. Or simple to say mode 1 is a phase with respect to neutral because it's a AC power supply is there. Phase with respect to neutral. Neutral with respect to the phase. So during the mode 1 condition diode is a forward bias. How it is a forward bias? Because you can see here output amplifier is a produced. So output amplifier is flowing this directions, okay, to close the circuit. What is output of the amplifier? What is the output of amplifier? Output of the amplifier is a V0 dash. V0 dash is equal to gain of the this op-amp. The gain of op-amp is a AOL. I have written gain of the op-amp int. Difference of the input voltage. What is the input voltage? V plus V minus. So difference of the input. This is the output of the op-amp. So this is output of op-amp is giving to the diode as well as the load. Your father is giving the 50 rupees. Okay, you are taking the your father is giving the asking to give the amount to that your sister, but you are the transfer charge you are taking 7 rupees and giving to the remaining amount 43 rupees. So 50 rupees it is equal to 7 rupees plus 43 rupees, 7 rupees for that your voltage drop, your consumption drop. Okay, so that is a V naught dash equal to V naught plus 0.7 volt. So substitute the equation number 1 into the equation number 2. So you will going to substitute it. So you have see the equation, numerator is a very low, denominator is infinity very high. So 0, okay, here is a 0 divided by infinity, 0 divided by infinity, the answer is a 0. So 0 it is equal to V plus minus V minus. So you can move this one on another side, V plus it is equal to V minus. So output voltage it is equal to input voltage. So during that V in greater than 0, output voltage is equal to input voltage. What about the mode 2 condition? It's a simply diode is a open circuit. Why? Because input voltage is less than 0 or bottom is phase is going this directions. When it is going this direction, what will happen? Diode is a reverse bias. So no current is a flow. So automatically what will happen? It is a reverse bias. So the circuit is a open conditions. The output voltage is 0. So you will going to draw the waveform. So mode 1 is a V in, okay, greater than 0, similar to the output voltage is a input voltage. Mode 2 is a 0. So this is about the precision rectifier. The precision rectifier, it has the drawback limitations. What is the limitation? Means it is not suitable for the higher operating frequency, 50 kilohertz to 100 kilohertz. It is not suitable. Then what to do? Then you can go for the modified precision rectifiers. And any other drawback? Yes, one more drawback. It is taking time to move from that mode 2 to mode 3, mode 1, mode 2 to mode 1. 1 to 1 to 1 to, like it is mode is operated. Mode 1, mode 2, mode 1, mode 2, like it is operated. But when mode 2 is a negative saturation, again going to the positive saturation means it's taking time variations. Okay, precision rectifier, it is just opposite. It is just opposite. Okay, your waveform, you have see that a waveform, just it is the opposite of the waveform. Okay, I will show you the waveform. See that one mode 1 condition is 0, mode 2 condition is a negative. Why it is coming negative? Why it is coming negative? Apply the KCL on the mode 2. Okay, you will going to get it on the negative. So that is the negative sides. Okay, R2 divided by R1. This is slope of the R2 divided by R1. So what is the angle? V in less than 0. Let's we are going to see about the main circuit diagram. This is the main circuit diagram. Okay, what is the circuit diagram? So previously you have connected the source here. Now source is connected to that minus sign. Minus sign place it is connected. Another one is a one more diode and one more resistance is added. During the mode 1 condition, D2. Okay, D2 is open. D1 is conducted. So when D2 is open means, so isolation between source and load. So no connection. So automatically output is equal to 0. During the mode 2 condition, what will happen? Mode 2 conditions. So mode 2 conditions, here is on, but here is off. Okay, you have possibilities to flow from here. Okay, minus voltage and possibilities to flow here. So apply the KCL at the point of 0 voltage. So input current is equal to output current. Incoming current is equal to outgoing current. So incoming current, what is that one? V in, Ohm's law, I is equal to V by R. V in divided by R1. V in divided by R1. V in is connected to the minus. So minus V in divided by R1. What is output? V out divided by R2. Yes, V out divided by R2. So from the equation, V out is equal to, okay, you can move this one, R2 divided by R1 into minus V in. So that's why it is a coming. Minus is a coming. So this is a modified precision rectifiers. Okay. The next one is a precision full wave rectifier means here half wave rectifier. The gain of the half wave rectifier is -2. So that's why you will going to get it on that one. This is a reverse. Reverse only you will going to get a negative half cycle only you are getting on that one. This is the things negative. So Vm minus gain. So -2. So when you will going to use the adder, so it will going to adding the summations. It will going to compensate it. So that's all about precision rectifier, modified precision rectifier and a precision full wave rectifiers. Okay, why do you go for the precision rectifier? The drawback of the off wave diode rectifiers. What is the drawback? The drawback, simple words, it's a threshold voltage drop. What is the threshold voltage drop? It's a 0.7 voltage drop. Why 0.7 voltage drop? Because of the silicon diode. Okay, you are go for that precision rectifier. What is the drawback of the precision rectifier? It is not suitable for that higher operating frequency. That is not suitable. That's why you are going for that modified precision rectifiers. It is the opposite. That's all.